Alright, so this is chapter 4, section 1, congruent figures. Okay, so we've talked about angles being congruent, line segments being congruent. We can also have figures being congruent. Figures being rectangles, squares, triangles, etc., etc., etc. This particular chapter in particular is going to feature ways to prove triangles congruent. And if in order to sort of prove figures congruent or polygons congruent, we have something called the definition of congruent polygons or congruent figures. And here's what it says. Congruent polygons have congruent corresponding parts, their matching sides and angles. When you name congruent polygons, you must list the corresponding vertices in that same order. Okay, so what does that mean? They give us a quadrilateral here. They give us another quadrilateral. They labeled it A, B, C, and D. And they have another one, E, F, G, H. We're also told, these are my two polygons, we're told that AB is congruent to E, F. AB is congruent to EF. We're told that BC is congruent to GFG or CG. BC is congruent to, I'm sorry, FG. We're further told, and these are all the segments. We're told that CD is congruent to GH. Since there's 4 sides, there's going to be 4 congruent, 4 corresponding congruent segments. And then we're told that DA is congruent to AG. Okay. So those are the segments. We're also told that angle A is congruent to angle E. We're told that angle B is congruent to angle F. And we're given that angle C is congruent to angle G. And that angle D congruent to angle H. So here's what we have. We have something called corresponding parts. Very similar to how we did the parallel lines and the transversal. We did corresponding, like top right, top left, the part where they in the book calls it matching. We also have corresponding sides and angles. So in this case, angle A corresponds with angle E, which is why A is congruent to E. B corresponds to F. C corresponds to G. D corresponds to H. Corresponding parts applied to angles, and it applies to sides. So I have AB, it's corresponding to EF. AD, or DA, corresponds to HE. CD corresponds to, oh, that should have been pink, GH, and etc., etc., etc. When all corresponding sides and angles are congruent, then the two figures are congruent. When all the corresponding sides and angles are congruent, then the figures are congruent. So we have four sides, so we have four pairs of congruent sides. We have four angles, we have four pairs of congruent corresponding angles. Therefore, I can say that figure ABCD is congruent to EFGH. I want you to recognize something, and this is important. How it's labeled is extremely important. EFGH. And it's labeled according to basically its corresponding vertices. A corresponds to E. So if I have A first, I have to have E first because they're corresponding angles. E corresponds to, or B corresponds to F. I have to have these guys in the second place because B corresponds to F. So if B is second, F has to be second. C corresponds to G in terms of angles, so since C is third, G has to be third. And then G corresponds, or D corresponds to H. I have to have them aligned in an order such that the corresponding angles line up next to each other. This isn't the only way to write this. I could write this in a number of ways as long as they line up. For example, I could have had it as I could have it as B, A, C, D. So I just switched to B and A, but then I'll have to write on the other side F, E, G, H. Because B corresponds with F. If B is first, then F is first. A corresponds with E, A is second, E is second. And so on and so forth. I can write them in any order or any combination thereof as long as they line up to their corresponding parts. So what's nice about that is when we write something, when we write a congruent statement between two figures, here we have triangle WYS is congruent to triangle MKNV. What's nice about this is that since corresponding parts are linked up when we write this congruent statement, I already know the corresponding angles, I already know the corresponding sides. W is first and M is first, so I say that angle W is congruent to angle M because they're written first. Then I can say that angle Y is congruent to angle K because it's written second. And then I can say that angle S is congruent to angle V because it's written third. So I can say that these guys are corresponding angles just because this is written and labeled the way that it is. In terms of the sides, I just combined two of them. Here's WY. So I can say that WY is congruent to MK because M and K are next to each other. WY is next to each other, M is K next to each other. And since this is a triangle, I need three pairs of these. Then Y and S in this thing is next to each other, so I can say YS is congruent to KV. And then for my third side, I just have to pick the two that weren't next to each other. So in this case, W and S, right? These guys weren't next to each other, so I can say WS is congruent to, and then MV, because MV are not next to each other. MV. So I can get all of that from the congruent statement, which is very convenient. I can get the corresponding angles and the corresponding sides from the congruent statement. If I know that two triangles are congruent, and here they give me the same two triangles, they tell me that angle angle W is equal to 62. They give me that angle Y is equal to 35, and they want to know what angle V is. Angle V corresponds to angle S. So I can use triangle sum theory to find out what the third angle is, because this is a W, Y, and S. So I know that since this is a triangle, they add up to 180. So 62 plus 35 plus, in this case, angle S, because this is part of that triangle, is equal to 180. Do the math. This is 97 equals 180. Angle S equals 83. And I know that angle S is congruent or equal to angle V. So since I know that S and V are corresponding and they're congruent, I know that angle V will equal also 83 degrees, or the measure of angle V. Okay. Alright, in order to prove two triangles congruent, I have to prove that, in this case, I have to prove that all their corresponding sides. So A is corresponding to this figure, A, B, C, and then E, D, C. Do I have enough to prove these guys congruent? I have that in terms of segments. Here's AB, and it's congruent to ED. I have a 4 over here and a 4 over here, so I can say that BC is congruent to DC because it's given in the picture that it's 4. Then I have AC is 6, and I have EC is 6, so I can say that those guys are congruent because they're both equal to 6. Corresponding angles, A is congruent to E, given in the photo, B is congruent to D, and then I can say that angle BCA is congruent to angles ECD because they're vertical angles. They're congruent. So I have 3 pairs of corresponding angles congruent. I have 3 pairs of corresponding sides congruent. So that's enough to say that the triangles are congruent. And the reasoning is definition of congruent triangles, or definition of congruent figures. So once you show that all corresponding parts are congruent, then you can say that the 2 figures are congruent. Using definition of congruent figures. So use that. We can use that in proof. Do I have enough information to say that these 2 triangles are congruent? I can say that DB is congruent to itself, reflexive. I have AD and DC corresponding. I have no idea about AB and BC. I have no idea about angle A and angle C. I have no idea about angle ADB or CDB. I have no idea about DBA or DBC. I don't have enough information, so I would say they're not congruent. Not enough information. All right, third angles theorem. That's how I write it. Third angles theorem. And what third angles theorem says is if 2 angles of one triangle are congruent to 2 angles of another triangle, then the third angles are congruent. What does that mean? In our first triangle, ABC, in our second triangle, EDF, I have that A is congruent. I would write it differently. I guess not. Let's be consistent and stuff. I'm going to write it all different. A, B, C, D, E, F. A and D are congruent. B and E are congruent. What third angles theorem says is that if the A is congruent to D and B is congruent to E, then I have enough information to say that C is congruent to F. Third angles theorem. If 2 angles of one triangle are congruent to 2 angles of the other, then the third angles are congruent as well. Yeah. All right, so here's the proof to that. It's a 7-step proof. It's a pretty decent proof. If A is congruent to D, B is congruent to E, then C is congruent to F. So we're going to prove that. So number one, it's given to me that A is congruent to D and that B is congruent to E. And number two, if they're congruent, then they're equal. So measure of angle A equal to measure of angle D. Measure of angle B is equal to the measure of angle E. Definition of congruency or congruent angles. Number three, we can say that I'm not going to write the measure because it's not enough space. A plus B plus C equals 180. D plus E plus F equals 180. And this is because of triangle sum theorem. Remember, the triangle sum theorem says angle sum theorem. Triangle angle sum theorem says that if they are triangle interior angles, the three of them add up to 180. Since they both add up to 180, I can say that they are equal to themselves. So A plus B plus C is equal to D plus E plus F. I'm not writing the angles because of space, but you would write the measure of angle A and measure of angle B, etc., etc. This is transitive property. I'm okay with saying substitution as well. So look what I have. I have from up here A is equal to D and B is equal to E. So what I'm going to do is I'm going to substitute A with D, B with E, plus C is equal to D plus E plus F. So I got D and E on both sides. Substitution. So since I have them on both sides, I can take them out. And in my next step, I can say that the measure of angle C, I've been waiting to write that for a minute, is equal to the measure of angle F. Subtraction property of equality. And then if they're equal, then they're congruent. Definition of congruency. Alright. Start with my givens. If they're congruent, then they're equal. All angles inside of a triangle equal to 180. Then I can set them equal to each other. Substitute the parts that are equal, subtract them out. Then I'm left with the measure of angle C is equal to the measure of angle F. And then if they're equal, then they're congruent. And that is the proof of the third angles theorem. Alright, so here they're going to ask us to prove things now using definition of congruent figures. So they give me all of this stuff. A and D. They give me all the sides, so I just have to prove these two angles. So thinking about how to set this proof up, I can say that these two guys are congruent because they're vertical. Then I can say third angles theorem for these guys, and then I have enough information to say that the two triangles are congruent. So my first is going to be all this givens, which is a lot. They gave me a whole bunch. Angle A is congruent to angle D. AE is congruent to DC. EB is congruent to CB, and BA is congruent to BD. Given. Okay. I can use the reflexive property to say that angle ABE is congruent to angle DBC. And I can use reflexive property, as I said before. And then I have enough information to say that angle E is congruent to angle C, because I can use third angles theorem. Two angles on one triangle congruent to two angles on the other, then the third angles must be congruent, so third angles theorem. Okay, so now I have all congruent angles and all congruent sides congruent. So then I can say that triangle AEB is congruent to triangle DBC or DCB. Definition of congruent triangles, or definition of congruent figures. I'll take either one. I'm used to saying congruent figures, but you could use triangles. So if you want to write the triangle symbol, be my guest. Okay. Alright, so that's this section. Hope you have a great rest of your day.